Greetings, everyone. This is Jeff Wilkerson, Professor of Physics at Luther College, bringing you the next of what to look for in the night sky. Looks like this is the week of November 6, 2023 this time around. We have been talking for weeks and weeks and weeks, months now. We've been tracking Venus in the morning sky. It's great. Venus has been just fantastic in the morning sky. We keep saying we're going to stop doing it, but not quite yet. Here's another week. When we left Venus last week, Venus was right on top of the star in, so we think of Virgo. Virgo is sort of a Y shape, a martini glass that looks like this with Spica down here. So Spica is the brightest star in Virgo, and then it comes up to this Y shape. And Venus was very close to, in the right half of the Y, Venus was very close to Zaniah when we left it last week. And it is tracking down, almost straight down the right side of the martini glass. Think of, there you go. There's a Venus. Think of it, Venus as a droplet of water sliding down the wall of that glass. And it's headed toward Zaniah down this direction this week. And by the end of the week, it is going to be right on top of Zaniah by the 12th, the morning of the 12th and the 13th. So you get up in the morning and you see Venus big and bright in the east. Now, if you live in the United States, I don't know about the rest of the world, but if you live in the United States, most of you will be going to daylight savings time this next week. And so all of this is going to be happening earlier in the morning. Venus is going to get up into the sky maybe by 4 o'clock now, and instead of 5 o'clock. And it's a good time to be out and see it is probably 5 to 6 o'clock. And so it's a little bit earlier than it was. But nonetheless, by the time we get to the morning of the 12th and the 13th, Venus is going to be sliding right past Zaniah. Another bright star, another bright pairing with a bright star right there. This is what you want to be out there observing. But before that happens, well, earlier in the week, on the morning of the 9th, early a.m., there's a thin crescent moon, only about 15% full. So you've got this moon that is going to be sliding right past Venus in this region of the sky. This is going to be a beautiful pairing with a bright Venus. Now, for me, the moon will have already slipped past Venus by the time it rises into the sky. So by the time it gets to, 3:30, maybe you could see if you had a really good horizon. 4 o'clock in the morning would be a better time to get out there and look at it, 4:30. Venus, the moon will already have slipped past Venus going this direction. Those of you who live east of where I live would have a better chance to see the moon really tight on top of Venus. So here I am in the central part of the United States. If you live east of there, you've got a better chance. Now, not way east of there, of course, but somewhat east of there in the eastern part of the United States, for example, that would work. And for you to be able to see the moon even closer to Venus, a very beautiful crescent moon, very near Venus, on the morning of the 9th, Thursday morning. So this is, we can't leave Venus yet. We can't leave Venus because it's going from one relatively bright star, 3.8 magnitude star, to another one down this direction and making a really close, tight pairing. This is a beautiful pairing after pairing. And then the moon has to join the party this week. But in the evening sky, as it gets dark, now, it gets dark earlier now, so as it gets dark, you look to the south and you see the Great Square Pegasus. And off the Great Square Pegasus, we love to look at the Great Square Pegasus this time of year, up high in the sky, up most of the night. And we love to look at Andromeda, which we identify as a V of stars, a sort of cornucopia of stars as we think about the United States Thanksgiving coming up. We do this every year. I know we do it. I don't think about it until we start to talk about it. But we think about this V of stars right here. You go out 1, 2 on the bottom. The bottom stars are brighter than the top stars in this V. But you go 1, 2, and in the bottom. Go up 1 to the top. Nerach is that star. You go up 1 to the top and that same distance, and you get to the Andromeda galaxy. The Andromeda galaxy is this big, beautiful galaxy, spiral galaxy. It's the biggest, most beautiful spiral galaxy in our sky, the closest. And we talk about it all the time because you can see it without any optical aid. You've got a good dark sky. You got to look at it and say, oh, look at that. There's a thumbprint. There's a slash of light that is the Andromeda galaxy. Now, we don't always, that distance is about 7 degrees. It's a little over 7 degrees, but it's about 7 degrees, so a little more than half a fist width up from Merak to the Andromeda galaxy up this direction. We don't always go the other direction, about the same distance. I don't think it's quite as far, but about 7 degrees, the same distance down the other direction, basically in a line. We're going to get to M33, the Triangulum galaxy. And you can see it too with your naked eye. I know because I've seen it. It's much harder, it's fainter, and it's this big fuzzy patch. Binoculars are going to be really helpful here as you do this. But if you've got a good dark clear sky and it's cool, it's cold, the moisture has frozen out of the sky, you would be able to see M33, the Triangulum galaxy, about the same distance from Merak as M31, the Andromeda galaxy, is the other way. And it's a big, we talk about surface brightness. The surface brightness is low for this object. It's spiral galaxies. Remember, the spiral galaxies are big conglomerations of stars, self-gravitating groups of stars, and they have, we often draw, as we do this, there's the bulge of the spiral galaxy and there's the disk, this big flat disk. But if you tip it up like that, then you're going to have that bulge in the middle, and you're going to see this spiral galaxy, the disk, out this direction. And you're looking through the thin part here. When I tip it up this way, you're looking down through the thin part of that, and you don't have as much integrated starlight. You don't see as much stuff. Looking through the thick part, you see a lot of light. It looks brighter. So these slashes, the spiral galaxies that are tipped this way to us often look brighter, smaller but brighter, because slashes of light. But the ones that are tipped up this way, they don't look as bright. Their surface brightness isn't as much contrast against the sky because of that. Just not as much stuff to be looking through, penetrating that way, not as much starlight adding up, and that's the case here. So you got this, it's big, and that's, it's big, but it's not all that bright. But I've seen it myself with my naked eye, and it helps to use my averted vision, to use the rods on the side of the eye to gather the light, to don't try to look right at it. Look at Merak and move my eyes around, and I start to pick up this hazy back patch down here. Then you get a pair of binoculars. You get a telescope, and it tends to wash it out. But you get a pair of binoculars, and you can see this galaxy down here. Now, the galaxy, as we said, these are these self-gravitating conglomerations of stars. All three of these galaxies, our galaxy, the Milky Way, Andromeda galaxy, and the Triangulum galaxy, are the three biggest galaxies of what we call the local group of galaxies. So we have a local group of galaxies, I'm going to say 80 to 100 galaxies. Most of them are little bitty small things, or little satellite galaxies that are orbiting around these bigger galaxies. So we call them dwarf galaxies. You have a lot of dwarf galaxies around here, hard to see. We have to work to dig them out of there. I think there's about 85 of them maybe known right now that we've identified, but there's more in there. They're so hard to see. They're so hard to dig out. So 80 to 100, let's say, of these galaxies, most of them these tiny little galaxies that are orbiting these other galaxies. And there's really sort of two big groups. The Andromeda holds one group, of which the Triangulum is over that direction, and so the Triangulum galaxy may or may not be part of that Andromeda group. It's over that way. It's closer to them than it is us over here. Milky Way is over here, and it has its own group of satellite galaxies around there. And so those galaxies are clustered around that way, and we're moving toward the Andromeda group. The Andromeda group and the Milky Way group are moving towards each other. We're the two biggest, Andromeda and our galaxy, the Milky Way, the two biggest galaxies in the local group, more or less 1 trillion solar masses. I tend to think, we're 200 billion stars. So 200 billion stars, but about 1 trillion times the mass of the sun. And that's not because most of the stars are bigger than the sun. It's because there's a lot of gas and dust and stuff in the galaxy. So a lot of that mass and dark matter, but there's a lot of that mass is other stuff other than stars in the galaxy. So it adds up to about 1 trillion. And the Triangulum galaxy is the third biggest. Andromeda is close, and the Milky Way and Andromeda are pretty close. I tend to think of Andromeda is probably slightly bigger, but it's hard to measure that actually. They're pretty close together in mass. The Triangulum galaxy is probably 50 times smaller, 50 times less mass. So it's quite a bit smaller, but it's still the third biggest galaxy in the local group, and then it's a pretty big drop off from there. So from there, the galaxies start to get quite a bit smaller. But you get a chance to say, okay, here's our local group. Our local group is part of the Virgo cluster, the Virgo supercluster, this bigger cluster of galaxies, and so we're a clump within this bigger group, this bigger expanse of galaxies this local group is. And they are the three biggest galaxies there. Us, our Milky Way galaxy, the Andromeda, and then the Triangulum. Go out and check it out and see if you can see those. Definitely don't miss the moon with Venus if you're clear on the morning of the 9th. And watch Venus as it moves from one bright star in Virgo to another bright star in Virgo. And that's the week ahead. So as always, thanks for watching, everybody, and I hope you have a great week ahead.